Water, the essence of life, the elixir that sustains our very existence. It covers over 70% of our planet's surface, creating a blue marble in the vastness of space. It sustains all life we know, from the tiniest insects to the tallest trees. From the smallest microorganism to the largest whale, water is essential. It is the lifeblood of our ecosystems. But have you ever stopped to wonder, where did all this water come from? How did it end up on our planet? The answer is a cosmic tale, a story written in the stars themselves, spanning billions of years. Our journey takes us billions of years back in time, to the very beginning of our solar system. We journey to the early solar system, a chaotic and violent place where the seeds of our world were sown. Imagine a swirling cloud of gas and dust, the remnants of a long-gone star coming together to form new worlds. This is where our story begins, in the heart of a nebula. Water is a simple molecule, two hydrogen atoms bonded to one oxygen, yet its journey is extraordinary. Yet its existence on Earth is anything but simple. It is a tale of cosmic proportions. It points to a complex and fascinating history, one that intertwines our planet with the vastness of space and the mysteries of the universe. Unraveling this mystery takes us on an incredible adventure, one that spans the cosmos. We'll explore the formation of planets, the violence of the early solar system, and the incredible journey of water from the depths of space to our home planet Earth. In the grand tapestry of the cosmos, not all places are created equal. Some regions are barren and inhospitable, while others hold the potential for life. For life as we know it, liquid water is a necessity. It is the elixir that sustains and nurtures life. And for liquid water to exist, a planet needs to reside in what scientists call the Goldilocks zone, where conditions are just right. This zone, also known as the habitable zone, represents a sweet spot around a star. It's a region where temperatures allow for liquid water to persist. Here, temperatures are just right, neither too hot nor too cold, creating a stable environment for life to flourish. Earth, bathed in the warmth of the sun, sits comfortably within this life-sustaining region. It is a perfect example of a planet in the Goldilocks zone. If Earth were a bit closer to the sun, like Venus, water would boil away into the atmosphere, making life impossible. If it were farther out, like Mars, water would freeze solid, locking it away from potential life forms. The Goldilocks zone is a delicate balance, a cosmic cradle for life. It is a narrow band where life can take root and thrive. Earth's position within the Goldilocks zone is a matter of cosmic luck. It is a fortunate alignment of conditions. It's a testament to the precise conditions needed for the emergence of life. Every element must align perfectly. This understanding guides our search for life beyond Earth as we focus on planets within the habitable zones of distant stars. It is our hope to find other worlds where life might exist. Our journey begins roughly 4.6 billion years ago. The solar system was a swirling nebula, a vast cloud of gas and dust. Gravity, the architect of the cosmos, slowly began to sculpt this chaotic cloud. At the center, the sun ignited, a fiery furnace fueled by nuclear fusion. Around the newborn star, the remnants of the nebula swirled and collided. Dust grains, drawn together by electrostatic forces, clumped into larger and larger aggregates. These aggregates, called planetesimals, became the building blocks of planets. Through a process called accretion, these planetesimals crashed and coalesced, gradually growing in size. Over millions of years, Earth, along with its planetary siblings, took shape. The early Earth was a hot and violent place. Bombarded by asteroids and comets, its surface was a molten sea. But within this chaos, the seeds of our planet's future, including the presence of water, were being sown. While Earth was forming, the early solar system was a cosmic shooting gallery. Comets and asteroids, icy remnants from the solar system's outer reaches, bombarded the inner planets, including Earth. Comets, often called dirty snowballs, are composed of ice, dust, and rock. Asteroids, on the other hand, are primarily rocky bodies. Both carry within them a precious cargo water. As these cosmic messengers slammed into the young Earth, they delivered their cargo of water. Over millions of years, these relentless bombardments contributed significantly to the growing reservoir of water on our planet's surface. The idea that Earth's water came from comets and asteroids is supported by the analysis of isotopic ratios. The ratio of deuterium, a heavy isotope of hydrogen, to regular hydrogen in Earth's oceans, is similar to that found in some comets and asteroids. Section 5. Cooling down Earth's early atmosphere. The early Earth was a hellish world, shrouded in a thick, toxic atmosphere. Volcanoes spewed lava and gases, including water vapor, nitrogen, and carbon dioxide, into the atmosphere. This early atmosphere was devoid of free oxygen, making it unsuitable for life as we know it. As Earth cooled, the water vapor in the atmosphere condensed. Torrential rains fell upon the molten surface, forming the first oceans. These early oceans were likely acidic and hot, a far cry from the life-teeming oceans we know today. Over time, the Earth's atmosphere continued to evolve. Volcanic outgassing released more gases, while the first photosynthetic organisms began to produce oxygen. This process, spanning billions of years, transformed Earth's atmosphere into the life-sustaining one we breathe today. The cooling of Earth and the formation of the early atmosphere were crucial steps in making our planet habitable. Without these processes, Earth would have remained a hostile and barren world. Section 6. Thea's impact, a defining moment. About 4.5 billion years ago, a cataclysmic event forever altered the course of Earth's history. A Mars-sized object, which scientists have named Theia, slammed into our young planet. This impact, one of the most significant events in Earth's history, had profound consequences. The impact was so powerful that it ejected a massive amount of material into space. Some of this material coalesced to form our moon, Earth's constant companion. The impact also tilted Earth's axis, giving us our seasons. Theia's impact likely played a role in the delivery of water to Earth. The impactor may have contained significant amounts of water, which were then incorporated into Earth's mantle and later released through volcanic activity. Theia's impact was a defining moment for Earth, shaping our planet's destiny. It highlights the chaotic nature of the early solar system and the role of chance in the formation of habitable worlds. Section 7. Mysteries of the deep unraveling water's origins. The question of where Earth's water came from has puzzled scientists for centuries. While the prevailing theory points to a combination of comets, asteroids, and possibly Theia's impact, there are still some unanswered questions. One mystery is the isotopic composition of Earth's water. While the ratio of deuterium to hydrogen in Earth's oceans is similar to that found in some comets and asteroids, it doesn't perfectly match any known source. Another question is the timing of water delivery. Did water arrive gradually over millions of years, or was there a late veneer of water delivered after Earth had already formed? These questions are still being debated by scientists. Unraveling the mysteries of Earth's water requires further exploration of comets and asteroids. Missions like Rosetta and Hayabusa 2 have provided valuable insights, but more data is needed to fully understand the origin of our planet's most precious resource. Section 8. The prevailing narrative. A cosmic cocktail. While there are still some unanswered questions, the current scientific consensus suggests that Earth's water came from a combination of sources. This cosmic cocktail theory posits that comets, asteroids, and possibly Theia all played a role. Comets and asteroids bombarded the early Earth. These icy bodies delivered significant amounts of water which accumulated on the planet's surface. Theia's impact may have also contributed to Earth's water budget, either directly or by releasing water locked within the Earth's mantle. This theory is supported by a growing body of evidence, including isotopic analysis, computer simulations, and observations of other star systems. However, the exact contributions of each source are still being debated and refined as new data becomes available. The origin of Earth's water is a complex and fascinating story, one that highlights the interconnectedness of our planet with the cosmos. Section 9. Water's significance, a universe of possibilities. Understanding the origin of Earth's water is not just an academic exercise, it is a quest that touches on the very essence of our existence and the mysteries of the cosmos. It has profound implications for our understanding of Earth's climate, the search for life beyond our planet, and the future of humanity. The presence of water shapes our environment and influences weather patterns. Water is essential for life as we know it. Without it, the complex web of life on Earth would not exist. Its presence on Earth is a testament to the unique conditions that allowed life to flourish on our planet. These conditions are rare and precious. By studying the origin of Earth's water, we can better understand the conditions necessary for life to arise elsewhere in the universe. This knowledge can guide our search for habitable worlds. The search for extraterrestrial life is driven by the search for water. Water is a key indicator of potential life-supporting environments. We now know that water is not unique to Earth. It is found in various forms across the solar system. It exists on other planets and moons within our solar system and beyond. These discoveries expand our understanding of where life might exist. Understanding how water is distributed throughout the universe can help us narrow down the search for life beyond Earth. It provides clues about the potential for life in distant worlds. As we continue to explore the cosmos, the story of Earth's water serves as a reminder of the interconnectedness of all things. Our quest for knowledge links us to the stars. Our planet, with its life-giving oceans, is a product of cosmic events that unfolded billions of years ago. These events have shaped the world we live in today.